Hello, dear students. Today we'll be starting a new module, Principles of Location. As per your syllabus, this is the considered as the fourth module, given as the fourth module, and this is in continuation of what we have studied in the previous three modules. The first module was concerned with casting of metals. Second module was on rolling. Third module was on forging and extrusion. And this fourth module, which is principles of location, is totally different types of uh, activities, which is mainly intended for machining of components. First three modules are concerned with making of parts through various methods, that is casting, rolling and forging. But whereas in principles of location we are going to learn how the components are machined on a machine. In this we broadly study the different principles of location, then how the location is done from planes or circular surfaces, and different types of clamping mechanisms for accurately keeping the workpiece onto the machine table. First, let us take the definition of a fixture and jig. Mainly, the fixtures are strong, rigid mechanical devices enabled to get easy, quick, and consistently accurate locating, supporting, and clamping against the cutting force. This is why a clamping device or a fixture is used for holding a component while machining on a machine tool. The purposes are locating, supporting and clamping, and not only that, it should have the facility to load and unload the component very easily, quickly, and it has to provide consistently high accuracy on n number of components which are going to be machined on the machine. And the result is faster and accurate machining with consistent quality, functional ability and interchangeability. We will see all these parameters in the coming slides. And jig is nothing but a fixture, but it has got the additional facility for tool guidance. As an example, suppose you want to drill a hole on a round disc as shown in this diagram. A hole is to be drilled at a distance x from the center of the disc, and the diameter of the hole is small d and the diameter of the disc is capital D. So without having any fixture, how do we make a hole on this disc? First, the procedure is explained in this slide. First, we have to clean and deburr the edges of the blank before accommodating the piece onto the machine. Then we have to take marking the location of the hole. First, we have to find the center of the disc because the axis is not marked onto the hole. So first we have to locate the center of the disc. Then by trial and error, again we have to mark the distance x from that center with a correct measuring instrument, maybe a scale or a vernier caliper or some other instrument, depending upon the accuracy of how much accuracy required for the distance x. After marking that distance, we have to position wise to bring the whole axis in alignment with the drill axis. Either adjusting the wise position with respect to the fixed drill axis or moving the drilling machine table and then locking the table, or moving the radial arm and head if it is a radial drilling machine. That is based upon what type of drilling machine you are going to use for making this hole. After fixing the blank, vise and the table, alignment is checked again, and if there is any error like eccentricity or some coaxiality of the drilling head with reference to the axis of the disc, we may have to adjust the position of the disc, and then we have to accomplish drilling. So this is a time consuming and laborious process, and not only that, if you want to repeat this for more than one component, the skill of the operator or the person who is doing the marking onto the disc uh, is very important, because the dimensions can vary component to component according to the way the operator is taking the dimensions, because every time he is marking the center of the disc by trial and error, and then he is continuing. So in order to avoid such complications and to get a consistently high accuracy on the hole, we have to go for using a particular fixture or a jig for the purpose of drilling this hole. Let us see how it is done. Take the first figure where the disc is marked as the part in this figure, and the jig is located on the outer diameter of the part, and it is clamped firmly by some screws or by some attaching mechanism, and the part outer diameter is taken as the locating diameter for the jig. And once the jig is located on the part, the distance x is accurately marked on the jig, and the hole is already made there, and this hole will act as a guide for the drill. And if you make the hole along this already made hole, considering that as a guide for the drill, it will reproduce the same hole onto the part with the same accuracy already built into the jig. So this way the hole can be very accurately transferred onto the part. And if you want to take n number of components, the same accuracy is transferred to all the n number of components. So that is the advantage of having a template jig for making these kind of holes. And according to the shape of the part, the fixture can be modified as shown in figures second and third, where the part shape is a bit different from the first figure. In the second figure, the part is having a projection, whereas in the third figure, it is having a hole at the center. And accordingly, the fixture is designed, and it is used for making holes according to the requirement of the part. Now, the basic purposes of jigs and fixtures for batch production. It is used mainly to eliminate the operator skill, eliminate the skill of the operator for marking, punching, positioning, alignments of making the part so that an accurate hole can be made onto the part. Then easy, quick and accurate locating, supporting and clamping the blank in alignment of the cutting tool. So that is done by having the fixture properly located onto the part. Then guidance to the cutting tool like drill and reamer. So that is why we have already made a pre-drilled hole onto the jig which will act as a guide for the drill or reamer. The fourth point is increase in productivity and maintain product quality consistently, because you are going to use the same fixture for n number of components. You are transferring the same accuracy to all the n parts without any change. So you get a very you will be able to maintain the product quality in a very consistent manner. The next point is reduce labor and skill requirement. You need not have a very skilled operator for if you use a fixture for the purpose of making the hole on the part. Then reduce the measurement and its cost, because the measurement is already made and the hole is accurately drilled onto the component. There is no need of again and again measuring on all the n number of components. So this is a large reduction in cycle time as far as the components are concerned. Then enhance technological capacity of the machine tool. Even if the machine is not very precise and accurate, and there can be some kind of misalignment, that is not going to affect onto the component, because the drilling is taking place considering the jig as the main guidance for the drill. So even if there is a small inaccuracy on the machine, it is not going to affect the accuracy on the component. Then the last point is reduction of overall machining cost and also increase interchangeability. How do you get the overall machining cost reduced? Because there is no inspection, there is no trial and error method in marking, so the process became fast, and the product produced by this method is interchangeable, because the same component can go to any number of assemblies with the same dimension. So the replacement of the component will be very easy because it is done with the same dimensions. So these are the basic purpose of using a jig or a fixture for batch production. Next we will go to the design considerations for jigs and fixtures. The jigs and fixtures may be operated manually, or sometimes it will be partially power operated devices. And jigs and fixtures are comprised of the main parts of the jigs and fixtures are base and body or frame with clamping features, locating elements for positioning and orientation, supporting surfaces and base, clamping elements, tool guiding frame and bushes, then indexing plates, some auxiliary elements and fastening parts. So let us see all these elements with reference to the figure. Here in this figure, the most important part is the base of the fixture or jig, and there are some supporting pins provided from the base which will act as a support for the component, and the component is sitting over the supporting pins, and it is further located from two sides which are perpendicular to the base. two locating pins are coming from one perpendicular side and another locating pin from the third side, which is perpendicular to both the planes. And you have got a jig bracket on the top, and on that you have got a clamping screw, and there is a mechanism for guiding the drill from the top. And this is a photographic view uh, of the same arrangement, and where uh, the speciality of this figure is that the top side can be is a swinging clamp arranged on the top, and the cover can be hinged because it can be moved up and down very easily for loading and unloading the workpiece from inside the jig. And you have got drill bushes not only from the side and also from the top. So drilling can be accomplished from top as well as from the side, and the component is located by having supports from the bottom as well as locating pins from sides. The factors considered during design, fabrication and assembly of jigs and fixtures. 1. Easy and quick loading and unloading the job to and from the jig or fixture. That is why in the previous diagram a hinged cover is provided from the top. Then use of minimum number of parts. That is one major point we have to consider while designing a jig. It should consist of minimum number of parts. Otherwise, each parts can contribute to some kind of inaccuracy which may finally affect the total accuracy of the component. Then use of standard parts as much as possible. You have to use standard items like screws or clamps or any other item. You have to use the standard items available in the market. Then reasonable amount of flexibility to accommodate slight variation in job dimensions. In the previous diagram, we can find that after there is some space, extra space available inside the fixture, so that even with the small variation in dimensions of the component, you can accommodate it very well within the space available in the fixture. Then prevention of jamming of chips and easy chip disposal. During cutting, the chip should not get clogged inside the fixture, and we should be able to remove the chips very easily from inside the fixture. Then easy, quick and accurate indexing system, where there are certain components which may require indexing like a gear, or you may have to do some holes from various sides, so you may require some kind of indexing incorporated into the fixture. So that should be very easy and quick if you want to do it onto the fixture. Then easy and safe handling, that is another important parameter. It should be easily the operator is able to handle the fixture with ease, and it should have sufficient safety. Then easy and quick removal and replacement of small parts. Then manufacturability of the fixture should be very convenient. You have to use that kind of material, and the manufacturing should be done without much difficulty. Then durability and maintainability, service life and overall expenses. For the expenses required for making a fixture or a jig, it should not be very high. Otherwise, the product cost will be comparatively it will be more if you use more expensive fixture for machining. Now we will learn arresting of all degrees of freedom of a blank in a fixture. This is one of the most important aspect as far as a fixture design is concerned. Any free body in space has got 12 degrees of freedom, and on machining it is necessary that all the 12 degrees of freedom are to be arrested. And when you take up the design of a fixture or a jig, this aspect is to be considered as an important aspect. And let us see how all the 12 degrees of freedom are arrested in the case of a component which is going to be machined on a machine. And this principle is called 3-to-1 principle for locating. See, in the first figure you can see that it's an isometric view with all the three axes marked on the figure, and you can you can see that there are three linear axes x, y, and z, and the movement is possible in plus and minus x direction, plus and minus y direction, and plus and minus z direction, and also clockwise and anti-clockwise rotation in all the three axes. So we have to arrest all these 12 degrees of freedom in the next figure. See, in the front view, the component is placed on three locating pins or three supporting pins from the bottom. So these three pins are set in the form of a triangle, and the component will be sitting without any shake on 3 points. So once it is located from the base with 3 points, how many degrees of freedom is arrested? There is one linear movement in the z direction is arrested. Then in addition to that, rotation in the x plane and also rotation in the y plane. So these two rotations, clockwise and anti-clockwise rotation in x, and clockwise and anti-clockwise rotation in the y-axis, and one linear movement in the z direction. So totally 5 degrees of freedom is arrested by providing three locating pins from the bottom. And after that, there are two locating pins provided from one side which is perpendicular to the base. Two locating pins are provided. So with these two locating pins, we are getting further 3 degrees of freedom. They are along the x direction and two rotations about the z axis. Along the x axis, 1 degree of freedom is arrested, and along the z axis, two rotations are arrested. Then the third plane, we have provided one locating pin. This will further arrest one movement in the linear direction, that is in the y direction. Now a total of 9 degrees of freedom are restricted by the 6 locators. Now clamping of the block restricts the remaining 3 degrees of freedom. We have to provide some clamping. This is known as the 3-to-1 principle, and that is how the component is firmly fixed onto the fixture before the machining is taking place. And the clamp is always the clamp is provided in a direction which will be opposite to the cutting force, so that the position of the component will not get affected even if heavy cutting force comes on the component. So this is how a 3-to-1 principle is employed to ensure that the blank will not the position of the blank will not get disturbed by applying cutting force. That position will not get disturbed and we get very consistent location of the component and the accuracy is ensured on the component. So with this we wind up this session, and uh, the remaining things, the type of location and additional supports and other principles we'll be seeing in the next class. Thank you.